Hello everyone, Jeb from Jeb's Project. Now let's see what we have on the bench today. Okay, on the bench today we have a Yaesu FT-1000MP. Doesn't power on. Well, let's, I've got it hooked up to the dummy load, see what happens. Okay, it comes on, it receives. Ooh, it shut right back off. Okay, let's reset it. Okay, leave it off for a minute or two. Okay, came on for a minute, so power supply is kicking in for a short bit and shutting right off. All right, let's pull the power supply out of it and let's take a look, see if we've got some capacitor issues. It's possible. Okay, we got the covers off of it. Now to get to the power supply is up here, but there's a control board underneath here. So you got a screw down in here, a screw over here, and two screws in the side, over here on the side. You've got these two screws here and here to take the fan up out of the way. Then you've got these two screws on the side. And then you slide it back just a little bit and lift the PA unit. Got to be careful, because then you got these two cables here. They go up into a little clip down in here. Then you can flip it over and set the PA unit over out of your way. On in here is the control unit. So you've got your, not sure yet, I think these are your 12 volt side. These are your 110 volt sides. You got to plug in over here for 110, which comes through to this plug here. So give me a few to dig into the schematics, and we'll see where everything goes. Okay, well, what we're taking a look at now is our direct 12 volt input on the back. Sorry about the focus there, just working on it. Brought in 12 volts on the back through the plug here. Let's see if we've got voltage. It's supposed to be, wow, I could quit shaking. Voltage here. Now, how about getting a meter up here where you can see it? Okay. This comes from the back directly to here. Okay, and if we didn't have the glare from the light, there we go. I'm hooked up backwards here, but that's all right. We got 12.6 volts. That's a bit low. Should be 13. Let me check my power supply here. Yeah, it should be. Okay, 13.6. Alright, so power supply. Let's try turning it on. We've got our voltage there. And we've got nothing. Okay, we've got nothing at that point. Alright, let's take a look at something here. Let's hook up our 110 volts back here. Okay. We'll take a look at our 12 volts from our power supply. Right there to right there. Let's turn the switch on. Came on. and dropped right back off. Okay, it turned on and then shut down. Okay. You can hear the relays kick in. So, but she wasn't putting out full voltage. She was only putting out about 10 volts. Let's check that again. I don't know what it is with the shakes today. But let's check that one more time. Okay, we got 0. Hit the power button. 8. Then shut right back down. And we still have started to come on. Alright, let's take a look at something here. We'll disconnect the positive from the power supply. Bring that up. And hook our positive. And our negative. And we still only have 7 volts. Okay. So we definitely got a power supply issue. Okay. I don't understand why this part's not working yet. I'll have to look at that differently. But let's go ahead and pull the power supply out and pull it apart. And another complaint with this radio is that the power plug in the back doesn't do anything when you connect external power to this when the power supply is not working. Well, the reason for that is down in here on these plugs right here, Yaesu has taken, if the power supply is installed, they plug this top one in to the power switch. And if the power supply is not installed, they take this plug down here at the bottom, move it up to the top, and plug it into the power switch. This, so it gives them the option to rather to install the power supply or not. If it doesn't have a power supply, you got to switch these 2 plugs. But if you've got the power supply, then it only works when it's switching 110 volts here. Otherwise, it's switching to 12 volts on this set of wires to engage this relay, which engages this positive onto this positive, so that the radio turns on. So there's nothing wrong with the plug in the back when you run 12 volts in. It just depends on which way these 2 plugs are connected. Okay, now back to preparing the power supply. Okay, to get the power supply out of this, you've got these 2 screws to pull here. And down here on the side, there's a small Phillips head that you have to loosen up to tilt the base forward. Let me loosen this one up down here. Alright, let's see if we can get this over here where we can tilt this face down. I need to loosen that screw up a little bit more. Actually, when you get the front tilted forward, this one here and this one here are the only 2 you need to remove to slide the power supply out. Alright, let me get the supply up out of here. Okay, once you get the power supply out of the radio, you got a screw here, a screw here. It takes these plates out, the end plates. Then you've got to take your ferrite beads off of your power wire here. and the unit slide. Once you remove the 6 screws from the bottom, your power supply slides out. You got to push your 110 volt input down through here and then feed these wires down through as you pull the unit out. Actually, it could go out the other direction. It'd probably be easier. Yeah, maybe not. Doesn't really make a difference. You still got to feed the wires one way or the other. Gotta work it out. Oh, the casing. Why they did it this way, I don't know, but okay. But what am I stuck on? Oh. Okay. Guess you got to go the other direction. In order to get to past that capacitor. Keep working them down through till we get it apart. There we go. Oh boy. I see what's going on already. Okay, I don't know if you can see it, but the top of these two caps are bloated big time. So I would say probably it's what it acted like with capacitors. Boy, they are bloated pretty good. Okay, let's check, make sure. Let's bring it down a little bit here. See if we can focus in a little bit better. I got a new camera coming, so you're supposed to have a better autofocus on it. But you can see the top of these things are bloated upward. Let's take a look at all the other ones. They look okay. Let's get some light in here so that we can see if any of them are leaking. Doesn't look like any of them are leaking. We should check these two. I'm sure that's probably what it is. We'll check the rectifier while we're in here and other components, but more than likely those two are the issue. Well, let's get her disconnected from the board and see what we can do. Okay, we got the capacitors out. Let's check them. Okay, we'll start out with the meter here. Oh. Select capacitance. And the negative side. Positive side. Okay, showing to be 217, 218, 220. Boy, they aren't constant, that's for sure. About 230 microfarad, 230.4. Okay, let's check the other one. .206, 214, 222, 230. Yeah, they just keep, they're not even holding solid. Alright, let's use this one. Take a quick gander, see what this has to say. You notice the display is a little crooked on it, but gotta get inside and clean it up. Alright, let's bring that in. And it says it's, it's saying it's a diode. That's incorrect. Let's change the probe here. A different probe. Oh, even that's saying it's a diode. Okay, it's saying it's a 251.6 microfarad cap. Okay, there's supposed to be 820. I would say that that's slightly out of whack. Let's check this one. And it's saying it's a 234.3 microfarad. So these are way out of whack. Them bloated tops gave it away. They're rounded on top. Okay, we got a new set of capacitors coming. We'll put them in and see what she does. Okay, we didn't have our voltage. Well, we had it at 13.8 volts for a short bit, and it dropped right off again. So it's cutting it back. It thinks it's going into over voltage. So we have to come down in here to this circuit. We've already replaced this C38 10 microfarad 50 volt because it was no good. So we put in a new one. It didn't seem to make a difference. We still can't adjust the voltage here. So let's check these two optocouplers. More than likely one of them is no good. But we'll go on and check them and see if they're any good. Okay. So we've replaced this capacitor. We checked this one, it was okay. I checked this one, it was okay. Checked this one, I checked this one. This one was no good, so we went ahead and replaced it. That was a 10 microfarad 50 volt. And we still have a problem with it, coming up the voltage and then dropping off. The next in the circuit here is the optocouplers, which is the isolation circuit, which tells it to whether it's going under voltage or over voltage. We're in diode mode on the meter. Let's check this one. Okay, we got 1.0. Let's move on to this one back here. Now if I can get onto it. And we're at 1.0. Alright, let's check this side. Let's reverse the leads and see what it does. Okay, we got 1.56. Okay, remember we're in diode mode, so let's check this one back here. Got nothing. Reverse the leads. We've got nothing. Okay, that would indicate that this optocoupler is no good. We've got input but no output. We've got input on the diode side, or the light emitting diode side on both of them, but the transistor side, the optical detector, we've got it on this one but not on these two. So we'll replace that optocoupler there. Actually, I'm going to replace them both and see what she does. She should at that point bring the voltage so it is steady instead of up and then dropping off. Dropping off would indicate that the rest of the circuit's still working. It's just what is the detection's not working. So we'll see what we can do. Okay, I replaced the control chip. Everything seemed to be through to the control chip. I was only getting 23 kilohertz. There goes my meter. And we needed at least 100 kilohertz in that range, so I decided to go ahead and replace the chip. So let's turn her on and see what we get here. Okay, we've got 14.1. Give it a minute or two here because it kept dying off, and see if she holds steady. So far we have replaced the large capacitors, two of the smaller capacitors, checked the output capacitors, and replaced the optocouplers. Had one bad optocoupler. So that may have contributed to taking the chip out. That, the capacitors. So as long as she holds steady, we'll adjust her. Let's adjust it down to 13.8 volts. See if we adjust. All right. We're going down. 13.9. 13.8. Let's see if we can get her as close to 13.8. Just a little too far. Just a little too far. Let's see how that's in. 13.802, I would say that's good enough. So, she seems to be holding steady. She'd have dropped off by now. So, it was in the control chip. As soon as the control chip warmed up, she'd drop right off. So, she seems to be doing good now. Alright, let me start putting her back together, and we'll put her back in the radio. Okay, well, the power supply is back together. I gotta get a wire tie yet to hold these chokes in. But other than that, she's ready to go back in the radio. Okay, the power supply is back in. See, it's running. It's got a little over 100 watts out. The bad chip, bad capacitors, and bad optocoupler. Wow. When the bad caps must have taken the chip out and the optocoupler out. So she's back up and running. She seems to be holding good and steady. Well, please subscribe and like. Would be appreciated. Trying to get to 500 subscribers. I'm hoping that won't take too much longer. Appreciate you watching. Catch you in the next one.